So refraction of light at curved surfaces. The refraction of light at curved surfaces means this is a, previously we discussed about the reflection of light. So reflection of light is different and refraction of a light is also different. First of all, in our daily life we see the different type of activities. For example, I want to read a textbook. Definitely, so I can use my eyes. If any problems, I want to use a spectacles, means definitely it will help to see the objects clearly. Some people, they are using the different type of opticals, means for example the watch repairers. Once you observe the watch repairer people, they are holding one type of glass in front of the eyes. So these are all the different type of situations what we have. Okay, now I'm going to say that, see, in our daily life we see that different type of activities I said, that is called as a refraction only, it will takes place. So in detail I am going to say that. So refraction topic. So refraction means if any ray is coming from infinity, we don't know. For example, one surface is there. So this is a surface. So any ray is coming from infinity, we don't know where it is coming from. Then if it will come and ready to fall on the surface of the particular area, then after that what will happen? It will ready to bend and again it will enter inside of the material. This is a, for example, this is water and so this is air. You feel that the air, inside of the air, the ray is coming from long distance. Then after completion of comes to the air and it will enter inside of the water. So you know that the bending of the ray is said to be called as a refraction. The bending of ray is said to be called as a refraction. So where we are going to observe that, see that this kind of the area, for example in this situation, this is air is called as a rarer media. So rarer media and inside of the water means other than this one. So that is called as a denser media. So here once you observe that this is a rarer media, denser media. First media is a rarer media, second media is a denser media. We have the two medias are there. This is the first one and second one. Example is the air and water, that we call as a, where the ray has to start, that is called as a rarer media. After refraction, after bending of the light, the ray has to enter, so that is called as a denser media. These are the two different type of medias are there too. So refraction. So this is the refraction. Now we'll go for the characteristics of a refraction of objects. For example, I will say that for this we will do one activity. What kind of activity means? You just bring one empty transparent glass. So bring one transparent glass and bring, so you just better to write one arrow symbol. Okay, so this is the arrow symbol on paper. You just draw a arrow symbol on a paper with some length in a horizontally, right? So once you observe that, you better to pour inside of the transparent glass some water. For example, water I am going to pour inside of the glass. Then next situation, this paper, for example this is a paper, on paper I kept like this. Then what will happen, you know, if I am going to bring this paper, the back of the glass, the transparent glass will shows that, if I am going to show that, it is called as the arrows are look like this, means both are arrow. So once you observe that there is a bigger arrow, now it is look like a small arrow. So what is the meaning of this one? What is the situation in this situation from one to other? Means the air, it will appear one object, and so water, inside of the water, if I am going to see something is different. So what is the difference between these two? Means the arrow is a bigger one, now it is a shorter one, right? So this kind of the short kind of images is called as a diminished images. In the reflection of light we already discussed that this is called as a diminished. Compared to the actual size of object, the image should be smaller. That is called as a diminished. Now we will go for the another one, virtual images. So virtual images is nothing but what is the virtual images? So we already discussed in a reflection of light. Again I am going to discuss. Okay, so here in this situation we are going to see that the virtual images is nothing but, so where we are ready to capture on a screen, that is said to be a virtual image, sorry, that is a real image. So we are unable to just capture on a screen is called as a virtual images. Okay, in detail we are going to discuss about by characteristics of a images, we'll discuss. So, and one more thing, inverted image is also there. For example, compared to the, I'm going to see that this is a arrow is look like this. If I am going to observe that kind of arrow while we are going to observe through the glass, then it should be look like this. There is a reverse, means inverted images. Okay, for example, the boy is look like this. Okay, so then next one, so here is a reverse action. So here when he is ready to appear as a reverse, then what we feel that is a inverted images. Then we have the different type of characteristics of a images are there. Okay, now we'll go for the conditions. So in our reflection of the topic, we have the different type of conditions. Here also we have the conditions are there. So what kind of conditions it will be, I'm going to discuss in detail, right? The first case, our first condition is if any ray, just see here. So this is a curved surfaces, it is not a mirror or it is not a, so lenses, whatever may be, right? And this is called as a, we already know that this is called as a principal axis. Principal axis. So here the principal axis is ready to divide the two equal parts of a curvature, that is different, right? Okay, now I'm going to say that if any ray is coming from infinity, then what happening in our first lesson, in our the reflection of light topic, definitely we know that if any ray is coming from infinity, after reflection it will be there in that situation. Now here what we have, so if any ray is coming from infinity, after refraction the ray is ready to pass through the focal point. So that is the first condition. Okay, if any ray is coming from infinity, after refraction through the curvature, then the ray has to meet to the focal point. So that is the first one. And second one, in this same situation, I am going to show that the second situation is simple. If any ray is just passing through the focal point, after refraction the ray goes to infinity and it is a parallel to the principal axis. So in second condition what it will be, this is the opposite of the, so first condition, if any ray is passing through the focal point, after refraction the ray goes to infinity and parallel to the principal axis. This is a second condition. Okay, now we'll go for the third condition. Third situation, so if any ray is passing through the center of curvature, so what is that? If any ray passing through the center of curvature, that is undeviated, means the reflection of light is not to present, means there is a, it is just ready to passing through the center of curvature, is a no bending of light has to take place. So this is called as a, these are the conditions what we have to, so use the refraction topic. So now the image formation formula is also there. The image formation formula is very important for that. So how to form an image, the derivation formula will be there or not, I am going to discuss in. Now see here, the image formation is there. Image formation, how to just form an image. For example, once you observe that this is a curvature is there. So this is a principal axis, what we have the principal axis, and I kept object on a principal axis at position O. So then see here, if I consider the two different type of rays, so one is that, so it is ready to fall on a point on a curvature. Then what happening after completion of the, after falling on a surface, then it should be ready to enter inside of the curvature. Definitely it should be refract, means the bending of a light. After bending of the light, the ray has to meet on a I position, is the image formation area. So in this situation, there is a I is an image and O is an object, and now I am going to draw one perpendicular line to the principal axis from the A position, that is said to be, it is called as a AN. So then next one, I am going to say that there is a making of a incident angle is called as a alpha, and here is a beta and this is called as a gamma. Now this position I am going to, this is a normal, and this normal position is ready to keep as a C. Okay, so now these are the center of curvature it is. Now we have the different positions, and these P is a pole what we have. And what about the N1 and N2? N1 is nothing but refractive index of a first media and second media. So first means you can feel that this is the air, this is the water, for example. Yes, so the rarer media refractive index is a N1, denser media refractive index is a N2. Now I am going to just calculate, and theta 1 and theta 2 is a making of a angles. The theta 1 is with a particular incident ray. So theta 1 and theta 2 is nothing but after refraction the meeting of the angle of a refraction, right? Then theta 1 and theta 2. Now I am going to just calculate, I am going to write the derivation. See here, the derivation where it will be there means if I consider that A N O, okay, so otherwise you can write that as a, okay, see this is called as a N O is a one of the A C O is a triangle, right? So once you observe that, so triangle A C O. Once you observe that, the sum of the internal angles is equals to sum of the exterior angles. Yes or no? So according to the mathematics wise, sum of the interior or internal angles is equals to sum of the external angles. See, for example, external means there is a out of the triangle. What kind of angle it will be? Theta 1. So theta 1 is equals to, what is that inside of the angles? So alpha and beta is the inside of the angles, means alpha plus beta. This is the first equation I am going to say. The next will go for the, and another formula is also there, that is said to be, it is called as a ACI. So triangle ACI. From this triangle ACI, then what it will be? So sum of the interior angles is equals to sum of the exterior angles. Once you observe that, exterior angle is a beta now. So here the beta is the exterior angle, and interior angles, once you see that, theta 2 plus gamma. So theta 2 plus gamma. I want theta 2 value. So here the theta 2 is equals to beta minus gamma. Because the gamma has to go out of the equal, then it became as a minus. So then it is said to be, it is a second equation. Do you know that Snell's law? In our lower classes we already know that is the Snell law is there. I am going to write the Snell's law. Snell's law is there. N1 sine theta 1 is equals to N2 sine theta 2. So this is the Snell's law. In our lower classes we already know that from the particular refractive index values we will get it. So N1 sine theta 1 is equals to N2 sine theta 2. Here I am going to substitute the theta 1 and theta 2 values in this particular equation. Then N1 sine theta 1 means, what is the theta 1? Alpha plus beta. Then is equals to N2 sine theta 2 is nothing but, what is that? That is a beta minus gamma. Okay, I am going to just omit the sign values. For example, let omit that are, otherwise both side I am going to leave the sign values. Then what will happen? Then N1 alpha plus beta only. Because of the reason sign values I am going to omit it. So N1 alpha plus beta is equals to N2 beta minus gamma. So only values, because, so here I am going to write that sign values. Okay, sign values. So negligible. Okay, so sign values are negligible. Then I am going to write that N1 alpha plus beta. Now I am going to write N1 alpha internally. Just I am going to multiply N1 alpha N plus N1 beta is equals to N2 beta minus N2 gamma. Okay, so now we'll go for the another value. What it will be there I am going to say. See, I'll write here. Listen, in this situation I am going to say that alpha, beta, gamma. I want alpha value, beta value and gamma value. How to write the alpha, beta, gamma? You know that the tan values, if I am going to apply tan alpha is equals to, once you observe that, tan alpha means what is that? Opposite by, what is that? Adjacent. Opposite by adjacent. What is the opposite value? An is a opposite. That's why an divided by adjacent means there is a NO. So here I am going to write. So then I am going to omit the tan value, means that's why we feel it is a alpha only. And then the tan beta is equals to same as this. Once you see that, the beta means the again opposite by adjacent. Okay, so what it will be? That is a an by NC. So here that is called as again beta. Okay, now and tan gamma I want. Then what it will be? Gamma means again an by Ni. So an by Ni is nothing but is a gamma. Okay, now I am going to write the full-fledged equation for that. So this is that I am going to substitute the alpha, beta, gamma in that above equations. Now see this N1 alpha means what it will be? An by NO. An by NO plus N1. So beta means what it will be? An by NC. Then equals to N2. Beta means An by NC minus N2 into gamma means what? So An by Ni. So An by Ni. Okay. So in that equation I am going to see that in that above equation, once you observe that An both side I am going to take An is a common. I am going to write. So by side, once you see here, An N1 into An by NO plus N1 into An by NC means I am going to write again here the equation I am going to take a common N1 into, so An is a common. For example, I want to take An is a common for these two. Okay, so An is a common. And here once you observe that N1 divided by, so what is that? NO, right? NO. Then plus N1 divided by, what it will be? NC. Then NC. And here once you see that, again I am going to take a common An. That, okay. So right side also, once you observe that N2 by, what is that? NC. Minus N2 by Ni. So here the An is gets cancelled from the both sides. Now I am going to, in this situation, NO, NC and everything is there now. I am going to call that N is nothing but N is near to the P value, means there is a pole. N is a imaginary number. Actually M is nothing but imaginary line I am going to appear writing. So I am going to write that instead of N I am going to write P. Then N1 divided by PO plus N1 divided by PC is equals to N2 divided by PC minus N2 divided by PI. So now I am going to write in another area, right? See, you know that once you observe that N1 by PC and N2 by PC is there now, I am going to write. So this is going to one side of a equal. Then what is that? N1 by C, N1 by PO. Then this side of minus is coming outside of a equal, means it became as a plus. Then N2 by, what is that? PI. Okay, see here N1 by PO and N1 by PC is there. Now in this situation PC and PC both side of equal will be there. So now N1 by PC is as it is, sorry, PO is as it is. So this is a O. And next one, what is that? This will go outside of a equal and this minus value will comes to So left side of A equal, what it will be, plus N2 by Pi is equals to what it will be, now N2 by Pc minus N2 by N1 by Pc. So once you observe that, N1 by Po plus N2 by Pi is equals to, now I want to take a common, N2 minus N1 by Pc. Okay, in this situation now I am going to say that, do you know what is the PO? Now comes to this situation. Okay, what is the PO? P2O is nothing but object distance. So definitely object distance will show with a symbol. What is that? PO is nothing but it is a U. Okay, right, object distance. So what about the PI? PI is nothing but it is a P2I, image distance. Okay, the image distance is a V. Now what about the P2C, means PC? So P2C is nothing but pole to center of curvature. The distance of pole to center of curvature is said to be, it is called as a radius of curvature is nothing but PC is equals to R. I'm going to substitute all the values in the above equation. Once you observe that, in this situation I'm going to write, so U is a, what is that? The object distance. According to the first lesson, conditions are there. What is the condition? Sign conventions conditions are there. So incident ray direction is a positive. The remaining all directions are negative. For that I am going to say that is a PO is nothing but it is a minus R, minus U. So then I am going to substitute in the above equation. Then see here. Okay, now see here, N1 by, what is the PO? Minus U. The next one, what it will be? So then plus N2 by Pi means V is equals to N2 minus N1 by Pc means R. Okay, so then I am going to write this, N2 by V minus N1 by U is equals to N2 minus N1 by R. This is the image formation formula. Okay, in this situation I am going to, one kind of small condition is there. For example, sometimes the radius of curvature it becomes 0 because no radius of curvatures are there. If I consider that R value become as a 0 means you should not take as a R value. The whole value become as a 0. That's why what it will be, N2 by V minus N1 by U is nothing but 0. So if it will go outside of A equal, N2 by V minus equals to N1 by U. So this is a one more formula. This is a formula and this is also one more formula for that, right? So okay, so erect images is nothing but which can be appear as a blur type of images, that is called as a erect images, and virtual images means which cannot be captured on a screen is called as a virtual images, and real images is nothing but which can be captured on a screen is called as a real images, and diminished images is nothing but if you observe that if compared to the object size the image size should be lesser, that is called as a diminished, and enlarged means, so here the compared to the object size the image size should be more than object, so then it is called as a enlarged. These are the different type of words we can use in our refraction opaque, right? So in this case we see that it is a condition one, if any ray is coming from infinity, so if it is just coming from infinity, so it will ready to fall on a curvature, definitely it should be ready to refract inside of a object. This is the first media and this is a second media. So if I am going to say that this is a, if any ray is coming from infinity and parallel to the principal axis, then after refraction the ray has to meet on a focal point. So this is called as a focal point, right? So this is nothing but is a first condition. The ray diagram first condition is this one, and next one case 2 is there, and case 2 is nothing but it should be the vice versa, reverse of this action. I will draw this here. Okay, so in this situation I am going to show that if any ray again, so if any ray is coming from focal point For example, this is a focal point. If any ray is coming from focal point, after refraction from the particular curvature, whatever may be, the ray goes to infinity and parallel to the principal axis. This is said to be called as a case 2. The condition, it should be condition. This is a case 1 is a if any ray is coming from infinity parallel to the principal axis after refraction from a curved surfaces, the ray pass through the focal point. And second condition is if any ray is coming from focal point after refraction through a curved surfaces, the ray goes to infinity and parallel to the principal axis. So here example 1 is there in this. In this example 1 question is there. So what kind of question it will be? So related to the our previous equation, the image formation equation is there or not, I am going to discuss. I am going to read out. A bird is flying down vertically towards the surface of water in a pond with a constant speed. So there is a fish inside the water. If that fish is exactly vertically below the bird, then the bird will appear to be. So to fish to be is nothing but simple. The question is very easy. So what kind of question? The bird is flying above a pond. For example, if I am going to consider that this is a pond, the above of a pond, the bird is flying. For example, you just feel that this is a bird. Okay, so the bird is flying above of a pond. See here that exactly the downward direction inside of the water, the fish will be ready to present. This is a fish, for example. So one fish is there here. So the fish is just moving. So once you exactly downward direction is nothing but it should be ready to consider as a distance. So it should be so exactly. You feel that is a straight line I am going to consider, right? Okay, now what I am going to see that, so here the radius of curvature is not present. That's why I don't want to consider as a radius of curvature. So what I am going to say that here the bird looks how it look like. For example, the fish is observing whether the bird is the same position or away from the position or below from the position. We need to just identify. For this, I am going to say that there is a distance from the pond to bird. It should be x. Right? I don't know what kind of the distance it will be. So that's why what I am going to consider, it should be called as a x. So inside of the water is also the fish will try to observe. So if I am going to consider the position of a object, for example, the bird should be appearing in some way other area. Now this distance I am going to considering as a y. If you feel that. Okay, so we don't know what kind of the values. This is a x I am going to consider. This is a image position. This is object position is a x and image position I am going to say as a y. We don't know where it will be. So then what I am going to say that there is a refraction n2 by v minus n1 by u is equals to, formula is like this only. Okay, n2 by v minus n1 by u is equals to n2 minus n1 by R. This is a formula. In this formula, what I said that the R is the radius of curvature is not present. That's why I'm going to consider this one. Directly I'm going to write. So once you observe that in this formula, what it will be object distance and image distance, I'm going to say that. So definitely it should be air. Okay. So then what it will be if I'm going to consider that it should be N1. Now it is a N1 and it is a N2. So N1 is equals to 1 here because every time the refractive index of the air should be 1. And N2 means we don't know whether water or something. We don't know what is the refractive index. That's why we feel as a N only. So then I am going to write the values here that the object distance and image distance everything I am going to write. So N2 means N. So N by V means what is that? So this is the object distance U. This is the image distance V. Now I am going to write that this is a, what is that? Y is equals to. So what it will be? N1 means what I said that 1. 1 by U means what? It should be a X. Object distance should say X. So if I am going to write the, both are ready to multiply. So what is that? Y is equals to N into X. So how it look like? This is a y is equals to n into x is nothing but multiplier of this one. For example, if you consider that x value is a 2 value, okay, and here the y value what it will be, n into 2, means y is equals to 2n. Is a multiplier of n value, is a refractive index. That's why, so definitely the image position is more than the object position, means far away from the actual position we consider. So you can take as a y is equals to 2n is there now. If x value is a 3, then y is equals to value more than this 2. So more than this 3. So multiplier of n will be there. That's why it should be called as a, there is a image position is more than the object position. That's why the bird will appear as a far away from the position. That is a reason. So example 2 will explain that. What is the example 2 means? A transparent sphere of a radius r and a refractive index n is kept in air. So at what distance from the surface of the sphere should a point object be placed on the principal axis? So as to form a real image at the same distance from the second surface of the sphere. This is a question. So in this question I am going to say that what the given words are there. So here first of all I want to consider as a sphere. So once you see that this is a sphere, you feel that, and here this is the principal axis I am going to consider. Listen, if the object is somewhere, there is an object position I am going to write, this is a O is a object. Okay, so then it should be ready to fall on a surface of a sphere. Then after that it should be refract and ready to enter. Again it should be comes to a refraction. It will make it as a, so image position is here. So this is the image position. Now what it will be? The condition is there. How much of object distance is there? Same image distance ready to present here. So that's why I don't know what is the object distance. I feel that this is a x is a object distance. Now here also we feel that it is a x, because how much of object distance is there, image distance is also ready to present. Then I need to consider as a, okay, right. So here what it will be, in a from condition the object distance should be minus x, because there is a left of the, or otherwise according to the sign convention formulas. Sign convention formula u is equals to minus x. So what about the v value? We don't know what kind of the v will be there. That's why the v is equals to infinity. So actually the condition is there, the image position is a same as the object distance. But here I am going to consider that the object distance is a minus x, then image distance we don't know where it will form. We feel that is a infinity. And now again I am going to write the refractive index value n1. It should be coming from A, that's why it should be called as a 1. N2 we don't know, means that is a refractive index is a n. Now I am going to substitute all the values. This is a called as a radius of curvature. Now I consider that there is a radius of curvature will be there. It should be same as is a r. Okay, so then I am going to use the formula n2 by v minus n1 by u. Okay, so here this is the formula we can use that. N2 by v minus n1 by u is equals to n2 minus n1 by r. This is the formula we can use it. So then I will substitute all the values in the above equation. Then n2 means what? N. N by v means what it will be? So infinity. We don't know where it is coming from. Okay. Then n1. What is a 1? 1 by u means what is that? Minus x is equals to n2. What is that? N minus 1 by r is as it is r. Okay, so minus into minus plus, that's why 1 by x is, this should be 0, because something by infinity is 0. That's why 1 by x is equals to n minus 1 by r. If I take as a reciprocal value, both sides I am going to take as a reciprocal, x is equals to r divided by n minus 1. This is a formula. Unknown distances we can by use the, so object distance should be calculating by using of a formula x is equals to r divided by n minus 1. Okay, this is also one of the formula, we can use it. Okay, example 3 will explain that a transparent sphere, example 3 I am going to write here, the example 3, third one. So in this third one example, a transparent sphere has a small opaque dot at its center. For example, if I am going to take as a, so one sphere, okay, on an opaque cube, so here there is a dot at the center point. It will be ready to appear as a dot on a center point. See, does the apparent position of the dot appear to be the same as to actual position when observed from the outside? If we observe from the outside, the position of the dot should be same or not. So here we can write the image distance. We can find out the image distances. Now I need to just write the radius of curvature should be r. Okay. Now here that is a refractive index values are the n1 is equals to 1. Here the n2 is equals to, we don't know, that is a n. Okay. So this is the situation if I am going to write. Then what it will be that? So on that particular image, see here I am going to write that. What is the image formation formula? There is a n2 by v minus n1 by u is equals to n2 minus n1 by r. This is the formula we need to use to calculate the image formation. So here in this situation, n2 by v, here that what it will be, that object distance is also r, because it should be on the position only. If I am going to consider that on the position, the radius of curvature is the object distance. Now it should be minus. Okay, so then I am going to write the formula. Here once you observe that n2 by v, what is the n2? So n1, sorry, n by, so v means we don't know, we can find out that as it is, v is as it is, minus n1 by u, n1 means 1, by u means what it will be, minus r, is equals to n2 minus n1, n2 means what is that, n minus 1 by r is as it is. Okay, so in this situation I am going to write the, once you observe that, so n by v plus 1 by r, okay, so is equals to, because minus to minus plus is equals to, this is separation, n by r minus 1 by r. So once you observe that, plus 1 by r and minus 1 by r will be gets cancelled. So then it should be n by v is equals to n by r. Okay, here that both side n values are gets cancelled. That's why 1 by v is equals to 1 by r. Then in this both side I am going to take as a reciprocal value. So that's why v is equals to r. What is that? That is a radius of curvature is a image position. We already know that, we will get it easily. So this is a formula and we will get the answer, right? Thank you. Lenses. So we have the different kind of lenses are there. So what is mean by lenses means the two surfaces of a light has to present. For example, two surfaces of a particular medium has to work. That is called as a lens. So here in this situation, in our reflection of light, we already discussed about the what kind of the, if any ray of light is ready to fall on a surface, curved surfaces, then what I am going to say that is a, the ray has to reflect. So that is a different. But in these lenses, so what I am going to say that the lenses are two surfaces, the first surface and this is a second surface. So what I am going to say here, this is a, what is that? It looks like a convex, right? So convex and concave, two types of lenses are there. So here what it will be, this is a convex surface. If I am going to observe this side is also look like a, so convex surface. How many surfaces are there? Two surfaces. That too it is a two convex surfaces. That's why we call as a name is a biconvex. So lenses, that is a lens. Okay. So biconvex lens. Okay, right. So it comes to the second situation, what it will be, it looks like a, so concave, and this surface is also concave. So how many concave surfaces are there? two concave surfaces are there. That's why. So biconcave lenses. Okay. So biconcave lens. Okay, in this third situation, once you observe that, in the third situation, what it will be? One is a plane surfaces is there, and another one is a convex surface. That's why what we are going to say, that is a plano-convex. So plano-convex lens. Okay, so plano-convex lens. So in this third situation, once you observe that, in a third situation is a plane surfaces is there, and as well as this surface is a concave surface. That's why what kind of that is a, one is a plane, means plano concave lens. Okay, plano concave lens. Then here we have, so two different type of surfaces are there. What is it? One is a looks like a convex, and another one is looks like a concave. Is it half moon, or otherwise the moon will appear like this only. So what we know, that this kind of the name I am going to write this. What is that? Concavo convex. What is that? Concavo convex lens. So these are the different kind of lenses are present in our daily lives. So we are going to do the, so two surfaces are there. I am going to show one example. See here it should be, it is a one circle, one sphere or circle will be there. So once you observe that it is a circle, each and every circle or sphere has a center point. Okay, so what I said, that is the center of the sphere, I said already, right? Again I am going to dictate. If I am going to consider one more surface is there, so that is also, this is a one more sphere is there. Then this sphere is also containing, so one center point, that is a C1. For example, this is C1 and this is a C2. So these two different type of spheres are right to comes closer, and it will look like appear as a, once you observe that this part is look like a biconvex lens. So biconvex lens is nothing but, now I am going to rub the remaining part. Once you see that, I am going to rub is the remaining part. So what it will be? So it should be like this once you see, and this I am going to rub. Then how it looks like? This is a biconvex lens. It's look like a biconvex lens. The how many center points are there? For C1 is nothing but center of the curvature is related to this curve, and C2 is related to the, so this curve. That's why how many center points are there for that? The lenses are having the two center of curvatures. Okay, so two center of curvatures are there. I am going to draw a principal axis. What is mean by principal axis? The principal axis is nothing but, so it is an imaginary line. It divides the two equal parts of a lens. Now it is called as a principal axis. Then we have the two center of curvatures, or two curvatures are there, and two center points of the curvatures will be there. So here, and once you observe that this is a middle part. Okay, now in this middle part, so the middle part is ready to explain that it should be designed actually in that curvature of the particular point where we are going to where the principal axis will meet a lens. That point is said to be called as a optic center, and in our reflection topic we discussed this part is a pole. Now the name as a, so pole will be changed the name as a optic center. This is a, what is the optic center definition means? The where the principal axis will touch or meet on a curvature, that point is called as a, so optic center. Then we'll go for the another one, and next one here, for example, I want to calculate the distances. So you already know that this is each and every center of curvature containing some normals in it. Okay, for example, I want to draw a normal to the particular surface area. So this normal is a, the two normals are there here. So normal is nothing but imaginary line. It is a perpendicular to the curvature. Now, okay, so here this is a this one dotted line is right to explain that this is a, so the distance from the axis. For example, distance from the optic center to the center of the curvature is said to be called as a radius of curvature is R1, right? And here from optic center to the center of curvature, this is also called as a radius of curvature. It is a R2. Okay, how many optics are lenses are containing two center of curvatures and two radius of curvatures, and as well as the one optic center, and as well as we have the different type of focal lengths also there. The focal points are focal length. This is called as a f1 and this is a f2, means the two focal points, and focal lengths also there. The pole to our optic center to the focal point is said to be called as a focal length is a f2. Okay, and so optic center to the focal point, again this is called as a f1. So here is a f1 and this is a f2. How many are there? The optics are containing, optic is nothing but lenses. The lenses are containing two center of curvatures, two radius of curvatures, two focal points and two focal lengths, but only one optic center has to present. Okay, here we see that the biconvex lens it is, and here it is a biconcave lenses. So here in this topic, what does that mean? Biconvex lens is a convergent lens or converging lens. Converging means after refraction the rays will meet on a single point. That is said to be called as a converging. And diverging is nothing but what is that? After refraction the rays is not to meet in a single point. The rays has to go in all directions. That is said to be this way. So diverging lenses. Now here the biconvex lens is a converging lens and biconcave lens is a diverging lens. Okay, converging and diverging. See here, I am going to take one example. If the rays are coming from infinity parallel to the principal axis, then after refraction from a biconvex lens, so it is not a concave, it is a convex. So biconvex lens, the after reflection, the all rays will meet on a single point on a principal axis. That is said to be a focal point or focus, right? Then go for the other one, that is the same rays are coming from infinity and parallel to the principal axis. The after refraction from a concave lens, okay, biconcave lens, see that the all rays are going in all directions. See, every time it is difficult to draw this kind of curvatures. That's why, so in our textbooks they simplified as this kind of arrow. Same diagram is ready to present here. See here though, by simplification of the drawing of a diagrams. So instead of this curvatures biconvex lens, I am going to draw a single line with a double arrow above and below. So two arrows are there. That is called as a biconvex lens. Then next, see what about the biconcave lens means? You see that the end of the arrow, once you observe that this is a if you know that the arrow, for example, this is an arrow means, so end, once you see that the back of the arrow we observe that same it will be ready to present here. So two ends will ready to present. This is a biconcave lens. So same as it is. So instead of this one, I am going to draw like this. It should be same, both are same, and it is also easy to draw the diagram compared to the curvatures, right? That is the reason. Here that conditions are there. So in the conditions, what it will be there means the case 1 will be there. In the case 1, what I am going to say that this is a biconvex lens. So double arrow. Once you see that the double arrow is said to be a biconvex lens is the principal axis. For example, if I consider any ray is along the principal axis means through the principal axis if any ray is coming, then it is undeviated. Actually it's a refraction lesson. Main concept means if the rays are ready to comes from a rarer media, it will enter into a denser media. Definitely it should be bent, but it should not be bent at the time of if rays are along the principal axis. Okay, so then it will meet on a axis. What does it mean? This is a optic center. So it is along with a principal axis and meeting on a optic center. It is undeviated. So if you just see that this is also biconvex and as well as, so irrespective of lenses, if you take as a concave or convex, the two type of lenses are same condition. The rays are, now it is a biconcave lens. Now in this situation also, if any rays are coming so along the principal axis, it is undeviated from the optic center. So this is the one condition, and we'll go for the other condition. This is a case 2, and case 2 will explain that what it will be. Now this is a biconvex lens. In this biconvex lens, if any ray is coming from infinity, we don't know where it is. So not only along the principal axis, it should be meet on a optic center. So it should not be deviate, means it is not to deviate any area. So see here, this is a passing through the optic center. Okay, it is not coming from the principal axis, it is not along the principal axis. If any angle, the rays are undeviated. Okay, so it is irrespective of lenses again. So if you take as a biconcave or biconvex, right? It is a biconvex. Then see that this diagram will explain that biconcave, the rays are just passing through your optic center, is undeviated. That's it. Okay. See, in the case 3, what does that means? Condition means already this condition we already know that. What condition it will be? If any rays are coming from infinity, so either biconcave or biconvex, whatever, biconvex or biconcave. So if any ray is coming from infinity parallel to the principal axis after refraction from a curvature or biconvex surface, the rays will meet on a focal point. This is a condition. Okay. So if any rays are coming from infinity parallel to the principal axis after refraction, the rays will meet on a focal point. Meeting on a focal point. See here, this is applicable to the biconvex surface. Now we'll go for the, so biconcave. If any rays are coming from infinity and parallel to the principal axis after refraction from a biconcave surface, the rays will appear to meet on a focal point. This is called as a, so small difference is there. It should be appear. The condition is same. So biconvex means this is a converging lens, means definitely it will meet on a focal point, but it is a diverging lens. So that's why it is not meet on a focal point. That's how it look like. It's look like to meet on a focal point. That is important, right? And now comes to the, so what does it mean? Another condition. This is a case 4. Okay. So case 4 will explain that if any rays starting from the focal point, okay, the rays will start from the focal point after refraction from a biconvex surface, then the rays are parallel and goes to the infinity That is the reason we have the focal point, whereas the starting of the parallel and coming from infinity, it should meet on a focal point. Whether will start from a focal point after refraction, the rays goes to infinity and parallel to the principal axis. Now again, it's a small change in the biconcave surface. So in this biconcave surface, what it will be? So rays are not meeting on a focal point. That's why what I'm going to say that if any rays are looks like to coming from focal point, if any rays are looks like to coming from focal point, after refraction, the rays goes to infinity and parallel to the principal axis. Look like means is imaginary. Okay, so that is the reason. That is the differences between the case 3 and case 4, right? These are the total cases. So rules to draw a ray diagrams. So what kind of the rules are there? For example, this is I need to just select as a, for example, it's a biconvex lenses I'm going to select. In this situation, first of all, what is the first step to just draw a ray diagram? Means first you select the object position on a principal axis where you want to keep a object. For example, I want to keep a object at O position, right? Okay, this is the first condition to select a object position on a principal axis. This is the first condition. And next condition, second condition will be, so draw at least two rays. So minimum two rays from the object. For example, now what does that mean? This is the first one. This is the first ray. Okay, so then and another one is a second ray is just here. At least two rays. You consider at least two rays from the object. Okay, then after refraction. So this is the third condition. What I am going to say now. So that is what is that? After refraction, to extend the rays. So for example, after refraction, so to extend the ray and extend these two rays. For example, this I am going to extend. Okay, so extend the two rays. Then where the two rays will meet, that point is the image position. So what it will be? This point is a image position. That is the third condition. Okay. So fourth condition, what it will be? Fourth condition means you draw a normal to the principal axis from the meeting point. For example, this is a meeting point. You better to just write that you can draw a one normal to the principal axis. So then it is said to be, it is a fourth condition. What is the first condition? The first condition, you select the object position on a principal axis. Then first condition. Second condition, you consider at least two rays from the object. And then the third condition is after refraction, extend the two rays. Okay. So the fourth condition, where the two rays will meet, that point is the image position, and draw a normal to the principal axis. So this is the position of a object, and now I consider as this is a I is a image position. Right? Okay, right. So one more thing is the fifth condition is also there. In the fifth condition, what it will be means the above of a principal axis is a positive. For example, the height of the object is a, for example, HO is the height of the object should be positive. Okay, the height of the object is the above of a principal axis means definitely is a positive. And then the below of a principal axis image should be, so below of a principal axis. That's why what I am going to say that it is a minus, is a negative. Okay, so the above of a principal axis is a object height is a positive, and below of a principal axis is a object image height is a negative. Right. So here from this is a optic center, we already know that. Okay, so this is the 5 conditions completed. In the after completion of the 5 conditions, object distance and image distance I am going to so identify. You know that this is a P2O is an object distance. We already know that the object distance will show with a symbol U. And image distance P2I, whole to image is showing as a symbol V. So object distance and image distance. Right? So these are the different type of values, and above a principal axis should be, and definitely it should be the object distance. Listen, just keep in your mind, according to the sign conventions in our particular sign conventions are there. What kind of the sign conventions are there means, so again I am going to repeating the sign conventions. In the first lesson we already discussed, again I am going to repeat. The sign conventions means the incident ray direction is a positive. For example, this is the incident ray direction. This incident ray direction is a positive. Okay, and every time the distance, object distance or image distance, whatever it may be, every measurements it will receive are ready to take from the pole only. In that situation, that is we call as a pole, but here it should be called as a optic center. Each and every distance will calculate from the optic center only. Right? And then image incident ray direction is a positive, and the remaining all directions are negative. And what about the third condition means same here what I discussed, that above of a principal axis taken as a positive and below of a principal axis taken as a negative. So these are the values and sign conventions also there. According to the situation, what is that? The incident ray direction is a positive, that's it. But the measurements will start from the optic center. That's why if you go the direction, it should be definitely it is a negative. Okay, see that this is the opposite direction. The direction of opposite only we can calculate it. That's why it is a minus U. But if you consider pole to image, Okay, optic center to image. What is that? The same direction of a incident ray direction only. That's why it should be called as a positive. This is a symbol, the sign convention values. That is very, very important in your sign conventions, right? So now we'll go for the conditions. What kind of conditions we discuss earlier? First condition, I'm going to say that the object at infinity. The first condition is there. If I'm going to keep a object at infinity, means is the unknown place I'm going to keep it. Okay, so now what kind of things are going to appear? For example, object at infinity means the diagram will ready to look like this. For example, see, so where the rays are coming, we don't know, right? So that's why it's a parallel to the principal axis. After refraction, the condition is already there that so refraction, after refraction, the rays will meet on a focal point. Now you see that this kind of thing, so meeting on a focal point is a point size. Okay, so what is the characteristics of a particular image? So image characteristics are very, very important. This is a long question actually. The object at infinity and object placed beyond C is a more 2-3 conditions are there. Then in that is a long question. This is object at infinity is there. What kind of characteristics? First character is the image is a point size. Image, okay, is point size. Okay, so simple. Image is point size. There is a one kind of characteristics. Now we'll go for the object placed beyond center of curvature. C is nothing but center of curvature. So I already said that the lenses are having the 2 center of curvatures and 2 focal points and 2 radius of curvatures are ready to present. Now according to that, I am going to consider the object position is a O, that is especially is a beyond center of curvature C1. So beyond center of curvature I kept the object. See, the above the principal axis will consider, and then I will consider 2 rays. So we'll following the conditions also. After refraction, the ray has to pass through a focal point. Here the any ray is just passing through a optic center, is undeviated. Now extend the rays after refraction. The meeting point is a image position, I said. Then what is the condition? Object placed beyond center of curvature. So where is the image position? Means image between so focal point and center of curvature. The image position is a between F and C, right? So what about the characteristics? Now here I am going to write the characteristics. What kind of characteristics? Once you observe that, compared to the size of the object, the image size should be less in this condition. Okay, so that's why once you observe that the object height is a O is bigger than the image size. That's what I am going to say that. If I am going to say that diminished image is diminished. Okay, so diminished is nothing but is a small size compared to the object. Okay, right. So now I am going to say one more thing. So what is that? It is an inverted images. Inverted means it's a reverse below of a principal axis. So inverted. Okay, so inverted. And what it will be? It is a real or not? So definitely it should be a real image. So these are the characteristics are there. So here image is a diminished, inverted and real. So these are the characteristics are ready to present if object is placed beyond center of curvature, right? Here we can observe that the object is placed between F and C. Between F and C is nothing but is between the focal point and center of curvature. Then the diagram is ready to looks like this. For example, in a biconvex lens, I kept a object position is between center of curvature and focal point. Once you observe that, this is the position of a object. Then after refraction, where will it will meet that? There is a image position should be beyond center of curvature. Okay, the condition is there. If I keep a object between center of curvature and focal point, the image is beyond center of curvature. And what is the characteristics of a image? So simple. Once you observe that, compared to the object height, the image height should be bigger one. Is nothing but enlarged. So what is the image characteristics? It is a enlarged. Okay, So enlarged, and next one it should be below of a principal axis means inverted. Okay, so next, so it is a inverted, and as well as what is that? It is a real image, it is not a dotted one. So that's why the real. These are the characteristics what we have. Okay, so this is a object placed between F and C. Now we'll go for the object placed on C. On C is nothing but on center of curvature. This is very important. Sometimes they may ask that how the object size, image size should be equal. So every time the object height and the image height is not equal, but which condition the object height and image height should be equal? In this condition I am going to show that. See, object placed on a center of curvature means if you keep object on center of curvature, so then after refraction the rays will meet at a point, that too it is a center of curvature, is nothing but I am going to say that what is the characteristics is the same size. Okay, so image characteristics is the same size, inverted is as it is same as is, so inverted, and next one is a real. So these are the characteristics of a particular condition object placed on a center of curvature, right? Okay, now see here in this situation the object placed on focal point. So where we will get the images again. These are the special category type of. So what does it mean? It is a, for example, if you keep a object on focal point, then see that so no image formation, because when the rays will meet then only it will form a image. But here that after refraction no rays are meeting in that particular area. So that's why what is the characteristics of a particular condition object placed on a focal point? So no characteristics or no image formation. Okay, so no image formation is ready to present, that is a characteristics. Nothing but no characteristics are present in this condition. Then it comes to the another condition, that is the object placed between F and P. So between F and P is nothing but, so this is a P, I am going to say that. So between the optic center and focal point, if I keep an object here, then they will get the image. This is a special category of the formation of a ray diagram. Once you observe that, it will that appear the beyond focal point. What is that? The image should be appear beyond focal point. It looks like a mirror. So why this looks like a mirror is nothing but another area, another medium is not entering. That's why backside of the same medium only to try to present a image, and that too it is a dotted line. I shown that. So why it is a dotted line means it is a imaginary. It is not a real images. Okay, so without real images means what we call that kind of images? That is a, what is that? Virtual images. So I am going to write that the characteristics. So virtual images, and next one, what is that? So it is a erect. It is not having proper shape. That's why erect. Okay. So erect. And what about the another characteristics of this one? Compared to the object height, the image height should be bigger. So image height is bigger one means what I am going to say that this is a magnified. What is that? So magnified. So magnified image is right to appear. These are the characteristics of a 6 conditions. The 6 conditions are very, very important. If you sometimes they may ask that long question, or individually also they may ask the condition wise questions. Okay, so that is very, very important, and especially that the characteristics is also very important to write it. Okay, right. The lens formula is right. Just calculate the lens formula. First of all, I need to consider one biconvex lens, because why we need to take as a biconvex lens is ready to form an image. So then I'll consider as a biconvex lens. Then I'll keep object at position O, means O dash is a object, and then I'll consider 2 rays from the particular O dash. Then after, if the O dash is the object height, and then after refraction the rays will meet a position I dash. This is the image position. Now, once you consider that where the refraction will take place, there is a P dash and here it will be a P. Is nothing but we already know that there is a optic center is a P and here it is a P dash. Both are refracting here. So then F1 is a focal point of a one medium and F2 is another medium focal point. Now in this situation, now it's look like a different type of triangles are ready to present in this. Now I will consider that. So triangles are there. Once you observe that P dash I, or otherwise you see that. So what does that means? The P dash I dash is look like a triangle, right? So what is that? You see that the P dash F1 is also triangle. These are the different type of triangles are there. Now I will consider that. Now P dash F1 is a one kind of the triangle. So now I will consider that triangle P dash F1, right? And P dash F1 is a one triangle, and so what is the next one? F1 I dash. What is that? Triangle F1 I dash. These are the two different type of triangles, and that too it is a similar triangles. How it's look like? So P dash F1 and I dash F1 both are looks like a similar triangles formula. So in this similar triangles formula, now I am going to write that opposite side, okay, our ratio we are going to take as a P dash. Now the P dash divided by opposites divided by I dash. Okay, the ratio of a opposites is equals to, so the ratio of a adjacents. Once you see that, the PF1. So what is the PF1? So PF1. So divided by F1I. So PF1 and F1I. So F1I. Okay, right. So this is a equation. Now in this equation, what is the F1I? I don't know. F1I is there. I want to expand this F1I. Now I will write that F1I is equals to, I want the F1I value means shall I write the Pi minus PF1? Definitely Pi minus PF1. So I want to expand this F1I. Now I will substitute the value in the above equation. What it will be that? So P dash divided by I dash is equals to, what is that? PF1 by, so F1I means that is a Pi minus PF1. This is the first equation what we want. Okay. So now we'll go for the another triangles formula. Once you observe that, how it looks like a triangle, one more triangle is also there. There is a O dash P is a one triangle. Once you observe that O dash P is a one triangle, and as well as the I dash is also one of the triangle. It's both are again similar triangles. Now I will write here. So triangle, what is that? O dash P. O dash P, and next one triangle is a, so what is that? I dash. So triangle I dash. Now both are again similar triangles. So what I said that from this similar triangles formula, I need to just write that the ratio of a opposites means what is that? The O dash divided by I dash. O dash divided by I dash is equals to, right? So what is that? OP divided by PI. OP divided by PI. Okay. So now what it will be? There's a small changes there. Here the O dash is equals to PP dash, correct? The height of the O dash is equals to PP dash. That's why I'm going to write instead of O dash is equals to PP dash. I'm going to write it. So then I'm going to substitute instead of O dash. What it will be? The PP dash divided by I dash is equals to, what it will be? Now OP by PI. OP by PI. In this situation, once you observe that this is the second condition I need to write. Okay, right, second condition is there. Once you consider that, the first condition will explain the P dash by I dash is equals to something is there. So here also second equation is also P dash by I dash is there. That's why, so both from first and second equation, 1 and 2 equations, okay, from 1 and 2 equations, what I am going to, left side values are equal. That's why right side values we are going to equalize. So what is that? So PF1, or otherwise I am going to write OP by, so PI is equals to, what it will be? PF1 by, so right, PI minus PF1. Okay, so both side I am going to take as a reciprocal value, is nothing but reverse that, okay, reciprocal value I am going to write. That's why I am going to write here the PI by, so OP is equals to reciprocal, what is that? PI minus PF1 divided by PF1, right? So here I am going to write the PI by OP is equals to, what is it? I am going to separate it, the PI by PF1 minus PF1 by PF1. So both are ready to cancel. Then in this situation, what is that? PI by OP is equals to, so PI by PF1 minus 1, right? So now I am going to write the PI value and OP value and PF1 value I am going to write. So in this condition now I will write it. Once, so here the PI by PO or OP is equals to PI by, so PF1 minus 1 is there. Now I am going to write that. So PI by, so OP or PO as it is equals to, I want to take a common PI here, that PI I am going to take a common. Once you observe that, 1 by PF1, so 1 by PF1 minus the PI is common, means what is that? Where it should be ready to not present, that's why 1 by PI. So once you see, in that if you multiply again, the PI by PF1 minus PI by PI means it gets cancelled. So that's why I am going to take as a both side I am going to cancel a PI. So 1 by PO or OP, whatever it may be. So PO is equals to 1 by PF1 minus 1 by PI. Okay, now I am going to substitute the values of a PO, PF1, PI. So what is a PO? Now the P to O is a object distance. That's why I am going to write PO is equals to U is a minus U. Why? According to the sign conventions, there is a minus U. And what about the PI? That is a PI is equals to pole to or optic center to image position. That should be, it is a minus, what is that? Not, it is not a minus. According to the sign convention, that object image position is a positive. That's why V is a plus V. So now what about the PF1? PF1 is nothing but pole to or optic center to focal point is a focal length is a F. So now I am going to substitute all the values in the above equation. That 1 by PO is minus U is equals to 1 by F minus 1 by V, right? If the minus will go outside of a equal, it should be become as a plus. That's why 1 by minus U plus 1 by V is equals to 1 by F. If I am going to write the 1 by F is equals in order. So 1 by V minus 1 by U. This is the lens formula to calculate the lenses of a unknown distances or unknown object distance or unknown image distance or unknown focal points or focal lengths of a lenses we can calculate, right? So example problem is there in this. This example problem, once you see that an electric lamp and a screen are placed on the table. On a table, the electrical lamp and as well as screen kept. So on that, in a line at a distance of 100 or 1 meter is nothing but 100 centimeters. What is that? From here to here is a 1 meter distance. Okay. Now I am going to consider there is a D. This is a 1 meter distance. Now, from the distance between the lamp and screen is a 1 meter, I kept as a d. Then, in what positions of a convex lens of focal length of f is equals to 21 centimeters will the image of lamp be sharp? Means, where you are going to keep a lens, then you will get a sharp type of image on a screen. That is the main question. So, what is the question they asked? That they kept a 1 meter distance between the lamp and screen. Okay, so between these two, where you will keep a lens, then you will get a sharp image. That is the main question. Now the given words I am going to write here. And what is the formula? What is the lens formula? Is that 1 by f is equals to 1 by v minus 1 by u is the formula what we have. Okay, so in this situation, I don't know the lamp to lens. That's why I am going to feel that this is a x. Okay, I am going to feel that is a x. And here the total distance is a d, and here this distance is a x. So what about the image distance? This is the object distance. Okay, so object distance, and this is a image distance. See, image distance I don't know. What does that mean? The d minus x. So what is that? D minus x is the distance of a image. So the total is at d. Inside the object distance I am going to consider as a x, means the remaining part is a d minus x. So that's why I am going to write here, there is a u is equals to object distance is a what I am going to say that x. Especially this is a minus x. Why? According to the sign conventions, minus x I am going to write that. The v is equals to d minus x. No minus will ready to present here. The v is a positive. That's why d minus x only I am going to write. So then next one I want to just substitute in the 1 by f is equals to 1 by v minus 1 by u formula. Then 1 by f is equals to here what is the 1 by v? So 1 by d minus x minus of 1 by minus x. Okay. So then minus to minus plus, that's why 1 by f is equals to 1 by d minus x plus 1 by x. So do you know that is a cross product? Okay. So once you observe that 1 by f is equals to, I am going to take as a cross. There is a x into 1 x plus 1 into d minus x divided by x into d minus x. Okay, so the plus x and minus x will get cancelled. 1 by f is equals to, so d by x into d means xd, and minus into minus, minus into plus minus x into x square. Right? Again I am going to take as a cross product. So what is that? xd minus x square is equals to, so f into d. Okay. And so I am going to consider as a all in a one side. That's why I am going to say that minus x square plus xd minus fd is equals to 0. I am going to multiply with a minus both sides. So then how it look like? X square, what is that? X square minus xd plus fd is equals to 0. So this is a one kind of the ax square plus bx plus c is equals to 0. So according to the coordinate geometry, we have that ax square plus bx plus c is equals to 0 will be there. So from this equation, how it will be find out the middle value, x value, how to find out means in that x is equals to, so I will write here. So x is equals to under root of plus or minus b. So you just see that the x is equals to plus or minus under root of. So I am going to write here the d plus or minus under root of b square minus 4ac by 2a. Okay. So b plus or minus, sorry, this is a b plus or minus under root of. So b square minus 4ac by c, 2a. So here, what is the b place? In that b place, what is that? Ax square plus bx plus c is equals to 0 na. So a means a is equals to 1, b means minus, what is that? d. And what is the c value? Fd. So now all values I am going to substitute in this equation. Then x is equals to d means what is that? Minus d. Minus d plus or minus under root of d square means the d square. Minus d square means so the d square, the minus d square minus 4ac. A means 1, c means fd. 4fd. Okay, divided by 2 into a means 1. Okay, so then x is equals to what it will be? Minus d plus or minus under root of d square minus 4fd by 2. So in this equation I am going to substitute the values what they given in our question. So here I am going to substitute the values. Then see that the d is equals to 100 centimeters, correct or not? In a meters they given, I am going to convert as a centimeters. Then f is equals to 21 centimeters. Once you see that in the question they given. So that's why I am going to write the x is equals to minus d means 100 plus or minus one time you can take plus, another time is you can take as a minus. So under root of d square means what is that? That is a 100 square minus 4 into f into d. F into means f means 21 into 100. Okay, so by 2. So if you simplify, you will get the value is a x is equals to, you simplify that, you will get one value. So what value will get it? There is a, so 70 centimeters. Okay, 70 centimeters. This is a one value I am going to consider as a x1. If I am going to take as a minus instead of this one, so minus if I am going to take that, what is that? It is a x2 is equals to 30 centimeters. They will get it. So here, what is that? Instead of that, if you take as a plus means 70, you will get it. So minus means you will get the 30 centimeters. You can calculate it that. Okay. So that is the value. Now see here, the focal length depends on surrounding medium. So this activity can shows this is the one kind of the activity can shows the whether the focal length is depending on the surrounding mediums or not. Okay, right. So now I am going to consider, first of all I want to take as a one jar or any this transparent what does it means container. You can take as a jar also. So you feel that you can take as a one jar and you fill it with okay water, and here the measurements are very important. Once I am going to take as a, so if I am going to, first of all you can bring a lens. So already what we calculated the focal length by using of a focal length formula, 1 by f is equals to 1 by v minus 1 by u. For example, I calculated the focal length of a biconvex lens. I got it. Okay, so in that situation, compared to this one, okay, is a 4 times bigger than the height. For example, the focal length is at 2 centimeters. Is a 4 times. Okay, you can take as a that much of height of the beaker. Okay, so more height beaker you can consider. Inside of the beaker, you fill the water. The above of a or so nearby the beaker. So the ending of the beaker you can just consider. Okay, then next what I am going to take as a, first initially what I am going to take in the inside of, before going to keep a water inside of the beaker, I kept one black stone in the bottom of the beaker. Inside of the beaker I kept that black stone. Then I am going to fill the water inside of the jar. Then listen, and now so I am going to bring a biconvex lens with a lens holder. Lens holder is there. I kept inside of the water. Then initially, once you observe that the lens and stone, the distances between these two is a less. I am going to keep near to a black stone. Okay. So then slowly I am going to increase the distance between the stone and lens. Then I am going to observe from outside. Up to which level means when the black stone will disappear, means that is a disappearing of a particular black stone in a particular lens. So what is that? Why if I am going to increase the focal length, this is the focal length. Okay, between the stone and lens holder, I am increasing means I am increasing the focal length. When it is a more focal length, it will disappear. At this activity, what we conclude that yes, the surrounding mediums are ready to affect on the focal length of a particular any lenses, whatever maybe lens we have. So the surrounding mediums is nothing but what is the surrounding mediums in that? The water is a surrounding medium, the air is also surrounding medium, and glass is also surrounding medium. So these are all different type of surrounding mediums can change the focal length of the lens. So that is activity can shows the surrounding mediums can change the focal length, right? So in the lens maker formula, what I am going to draw that I want to just calculate the lens maker formula. First of all, I want to consider for this, I want to consider a one biconvex lens. Okay, here the O is a object position. I am going to consider the rays. So what is that? There is a ray is right to fall on a curvature at a position. Then after that, the ray has to enter inside of the lens. So definitely it should be refract, because one surface means it will try to enter, and then after refraction the ray has to travel from A to B. Then again it comes to the, so this media means lens to outside, again it should be again bending. There is a refraction will takes place. Again it will try to form an image on a principal axis is a eye. So for example, if I consider only one side of the surface, then where will be ready to form an image? So definitely this ray after bending of one area, then it will make an image at Q. So clear? So if I am going to feel that the object is ready to image, incident ray is ready to fall on a position. After that, the 2 times refraction will take place. So one time at A position, again it will enter and it will travel to the A to B, and B position again it is right to refract. Then again it will make an image I position. If the B position is not present, no other surface is not present, then it should be make an image at Q. So now the object distance is a U, the image distance is a V. And R1 is the radius of curvature is the first media, and radius of curvature is the second media. Then NA, NB is also there. What does NA means? The first refractive index, first refractive index, and this is the second refractive index. And again it will come to the air means that again the first media only is a N base A, NA and NB. So these are the values, and now I want to calculate that. First I want to say that I don't want to go for the other area. So if the A position only I am going to consider. Now in this condition what I am going to say that, so image formation formula is also there. That is first of all image formation formula. So image formation. So formula. What is that formula? So N2 by V minus N1 by U. Okay. So N2 by V minus N1 by U is equals to what it will be? Okay. So N2 minus N1 by R. That is the formula. In this formula I am going to substitute first situation. So first situation I am going to write it. Okay, the first situation is at A position. Okay, at A position. Now I am going to consider what is the N value is a N1 is equals to NA. Correct. So first media is a N1 is equals to NA. NB is equals to N2 is equals to NB. Clear? The object distance should be, so what is that? The U is equals to, what is that? U only. Object distance is equals to U only, but it should be negative U. Okay. What about the image position? Now in this situation we don't know that the V is equals to, okay, what it will be? Only first side will be ready to present means we don't want to consider as a V again. So now it should be called as a X. So that's why is a X. Is a plus X or minus X? Plus X. So R is equals to what I am going to consider? The radius of curvature I am going to consider as a R1 plus R1. Now I am going to substitute all the values in the above equation. Now, so N2 by V, what is that? N2 means NB by V means what is that? So X is equals to or minus N1. N1 means what is that? N base A divided by, so what is that? U. U means what? Minus U is equals to N2 minus N1. NB minus N base A divided by R means R1. Okay. So now here that is a minus to minus plus will be there na, NB by X plus NA by U is equals to N2 minus means NB minus N base A by R1 is the first equation. First equation. Right? Then we'll go for the second condition at position B. B at B position now. Okay, at B position, what I am going to say that, see here, so now I will consider the B value. What about the object position? Now I will consider that X is the object position. That's why the U it should be become as a X. Okay, and then what about the V value means there is a V should be V only, that took plus V only. And now in that situation, what I am going to say that there is a R is equals to minus R2, radius of curvature is a minus. Then here in this situation there is a N1. Now what is the first initial refractive index? N base B. Now it is a N base B and N2 is equals to N base A. And this is the formula is there. I am going to substitute all the values in that formula. That N2 by V means what is that? N2 means NA by V means what is that? V. So V is V only plus V only minus N1 by U. What is the N1? N base B by U means what? X is equals to, now I want to write that NA N2 minus N1 now. NA minus NB by, what is that? Now it should be minus R2. If I consider the minus, once you observe that NA by B minus NB by X is equals to, I want to take as a common minus, then NB minus NA divided by minus R2. Then minus will get cancelled. Here that I am going to write NA by B minus NB by X is equals to NB minus NA by R2. Once you see that, this is the second equation. From first and second equation, I am going to add both sides. Okay, so equation 1 plus equation, so 2 I am going to add. Then see here, what is the left side value and right side value? NB by X plus NA by U is plus NA by V minus NB by X. Okay, so right side value. Now I am going to write, what is that? NB minus NA. NB minus NA by R1 plus NB minus NA by R2. Right, NB by X, NB by X is a gets cancelled. Here that NA is a common. NA is a 1 by U plus 1 by B is equals to, what is that? Now NB minus NA is a common. So then 1 by R1 plus 1 by R2. Okay, so then in this situation I want to take as a, I want to divide this NA, it goes to the outside of a equal. What it will be there? 1 by U plus 1 by V is equals to, what it will be? NB minus NA by NA. So into 1 by R1 minus 1 by, so plus 1 by R2. Okay, then I want to write the sign convention values. Now in this situation, so if I am going to consider this is a 1 by u plus 1 by v as a, what is that, 1 by f. That's why 1 by f is equals to what it will be. Now I am going to separate it. What is that? Nb by Na minus 1. Directly I am going to cancel it. So then it should be, now what is that, 1 by r1. So plus 1 by r2 become as a minus 1 by r2 because of the reason then it should be, so r2 is a minus r2. Okay, this is the value. So according to the sign conventions, now here I want to consider this is a total value is a n. So what is the one last formula? 1 by f is equals to n minus 1 into 1 by r1 minus 1 by r2. So this is the formula what we need to calculate the lens formula. Okay, if I think the 1 by f is equals to n minus 1 into 1 by r1 minus 1 by r2. So here the example problem they given. In that example problem, what does that mean? There is a, what is the focal length of a double concave lens? So they given as a concave lens. So in the double concave lens kept in air, so right, with two spherical surfaces of radius is a, r1 is equals to 30 centimeters and r2 is a 60 centimeters they given. Take refractive index of the lens as n is equals to 1.5. The question they given as clearly r1 and r2 the values they given, and then n value also they given. You find out the f values, the focal length. Then how to find out the focal length? The formula already there, that it is a, so lens maker formula 1 by f is equals to n minus 1 into 1 by r1 minus 1 by r2. This is the formula. Now in that values what they given, I am going to write it. r1 they given is a 30. Now according to the sign convention that it should be become as a minus 30. Then r2 they given as a 60 centimeters. Now according to the sign convention it is a plus only. So then what it will be, n value is a 1.5 they given. These are the values they given. Now I am going to substitute the values in the above equation. 1 by f is equals to, what it will be, 1.5 minus 1 into 1 by r1 means 1 by minus 30 minus of 1 by 60. So now I will write it here. Now 1 by f is equals to, what it will be, 1.5 minus 1 is nothing but 0.5. So then here 1 by 30 minus means minus 1 by 30 minus 1 by 30. If I am going to take as a minus means, so you just take a common minus. So what is that? 1 by 30 plus 1 by 60. So you take as a LCM or otherwise cross product, you can do it anything. Just 1 by f is equals to minus 0.5 into 60 into 1 60 plus 30 into 1 30 divided by 6 these are. Okay, so 1800, 60 30s are. Okay, so then I am going to write the 1 by f is equals to, you know that there is a 0.5 is a 1 by 2. So minus 1 by 2. Okay, then what is that? 60 plus 30 is a 90 by 1800. So 0 0 will cut. Then you know that there is a value is a 9 ones are. Okay, so 9 twos are 18 means 9 20s are 18, right? So what is that? 1 by f is equals to minus 1 by 2 into 20. So what is the value? 1 by f is equals to minus 40. Now what is the reciprocal value? I need f value. F is equals to minus 40 centimeters is a answer. Then I got the value is a minus 40 centimeters.